Good morning. I'd like first to thank the organizing committee of HMET 2020 for providing us this opportunity. Through this short message, we would kindly invite you to contribute a manuscript to the special issue of the Archive of Environmental Contamination and Toxicology. This special issue is about environmental fate and effects of technology critical elements. My name is Hui Deng. I'm an assistant professor from Trent University, and I'm speaking on behalf of the editor-in-chief, Dr. Christopher Metcalf, and two colleagues, guest editors, Dr. Montserrat Filila from the University of Geneva, and Dr. Dario Manovic from the Ruda Boskovic Institute. First, let's define what are the technology critical elements. So our modern high technology society and economy are increasingly dependent on the so-called technology critical elements, which are vital to the manufacturing of a wide array of advanced and innovative technologies: electronics, medical imaging, renewable energies, military applications, and so on. On the other hand, raw material is defined as critical by the risk of supply shortage, subsequent impacts on the national economies. And accordingly, several elements, groups of elements or minerals fall into these definitions. 14 according to the European Commission and 35 according to the US Department of the Interior. But in this special issue, we want to focus on a few elements of critical interest. And as you can see, these elements span over the entire periodic table. From left to right, you recognize lithium, the rare earth elements, the high field strength elements, tungsten, rhenium, the platinum group metals, gallium, indium, germanium, antimony, tellurium. And all these elements have something in common. They are known for their high dissipative losses from various anthropogenic emissions, from direct losses through mining or refining, smelting activities, but also the progressive burdensome disposal of electronic waste. A recent report showed that 44.7 million metric tons of electronic waste are being generated per year, but only 20% are properly recycled. And that lead to potentially severe and unforeseen impacts on the nature and environment. And therefore, we wish to welcome manuscript that either describing original research or provide a short mini review from various disciplines, as we hope that this special issue is inter and multidisciplinary. Therefore, topics of interest could be the analytical methods that help us to determine the total concentrations, but also the chemical speciation of these elements in various environmental matrices. We also welcome manuscripts that focus on the fate of these elements in various environmental media, on bioaccumulation and transfer of TCE within the food web, on the toxicity and ecological risk assessment of these elements. We also wish to receive manuscripts that deal with source identification, that means the ability to track and proportions emission sources of TCE to the environment, that help us to interlink the anthropogenic pressures and the environmental impacts. Therefore, if you might be interested and willing to contribute a manuscript to the special issue of the Archive of Environmental Contamination and Toxicology, we would kindly invite you to visit our website to look at the author guidelines and the manuscript submission process through Editorial Manager. And so, I'll be glad to receive an email from you about the potential contributions. In the meantime, we'd like to thank you for listening to this short message, and we look forward to hearing back from you. We wish you all the best. Thank you very much, and bye-bye.